Hello everybody, welcome to grade 12 winter school. In this video I will discuss trigonometry. Now this is the second part of trigonometry and the key concepts in this question are identities, double and compound angles, reduction formula, equations without a calculator and equations general solution. And this question counts 24 out of 150, which results in 16% of the paper. And then I want to encourage you to practice solving trig problems. And then also you can watch my playlist and videos on double and compound angles. That will really help you to reinforce your understanding of trigonometry. Let's look at the question. Now, as you can see, the question counts 24, so you should not spend longer than 24 minutes on this question. At number 6.1, the three questions here, they are all about equations without a calculator. 6.2, this is your identity, and you will see some double angles, negative angles, another double angle. This is a reduction formula, grade 11 work. 6.3, that is your general solution, and then 6.4 is again a double angle and solving it without a calculator. Let's look at the actual question now. 6.1, in the diagram P, -5, 12 and T lies on the positive x-axis. Angle POT is equal to theta. Answer the following without using a calculator. 6.1.1, write down the value of tan theta. So tan's ratio is y over x. And there's point P, so the x is -5 and the y is 12. Therefore, the ratio is tan theta is -12 over 5 y over x for 1 mark. 6.1.2, calculate the value of cos theta. So cos's ratio is x over r, and we don't know r. So we're going to calculate r with the theorem of Pythagoras, and r is in fact OP. So in x's place we substitute -5, in y's place we substitute 12, and then OP is 13 units. Therefore, cos theta is x over r is -5 over 13. Where's the marks? Theorem of Pythagoras, OP, and then cos's ratio. 6.1.3, SAB is a point in the third quadrant such that TOS is theta plus 90 degrees and OS is 6,5 units. Calculate the value of B. So the sketch, you find it down here. So in fact, there at S, x is A and y is B. So that is the thing that we're looking for, is that y coordinate. So we start with sin theta plus 90 is y over r, and the y is B and the r was given 6,5. And then sin theta plus 90, that reduction formula is the same as cos theta, which is B over 6,5. And then in the previous sum, we calculated that cos theta was -5 over 13, and then we solve B, that B is -5 over 2. And then where's the marks that you saw sin theta plus 90, and then the reduction formula sin theta plus 90 is cos theta, the substitution for cos theta, and then B's answer. 4 marks. 6.2, determine without using a calculator the value of the following trig expression. Right, we start with sin to x, and then there's a cos minus x. So cos minus x is a negative angle, and I'll do it here for you. you say the cos of a negative angle is equal to positive the cos of the positive angle. And then plus cos 2x, and then we find a sin 360 minus x. Now in the cast diagram, there's your cast diagram, and then this one is the 360 minus x quadrant, and cos in that quadrant is negative. Therefore, it will be sin, actually minus sin x. And then sin 180 plus x, this is the 180 plus x quadrant, the third quadrant, and sin is negative there, so that one will also be minus sin x. There, I did it for you. Then in the next step, this sin 360 minus x that became minus sin x, this minus will go to the front there. And then you must be able to recognize the compound angle. Sin 2x cos x minus cos 2x sin x, that is the compound angle for sin alpha minus beta. So that one we will write as sin 2x minus x, and then 2x minus x is just sin x over sin x. They cancel each other out, and the answer is -1. So where's the marks? The cos minus x that became cos x, the sin 360 minus that was minus sin x, the sin 180 plus that became minus sin x, the compound angle, and final answer. 6.3. Determine the general solution of the following equation. Now your first problem is that this is sin squared and this is cos. So what you can do is down here, you find, I wrote down for you the squares identity. And then if you let cos squared walk across, you get sin squared x is the same as 1 minus cos squared x. And that's what I'm going to do in the next step. In sin squared's place, I'm going to substitute 1 minus cos squared x so that everything is in terms of cos. And then I'm going to multiply in the 6, and then I'm going to add my like terms. And what I also did was, since there was a negative with the cos squared, I divided right through by negative, and then the signs changed. Then you're going to factorize this. Now this is as if you have 6x squared minus 7x minus 3 is equal to 0. And that one you can factorize and write it as 3x plus 1, 2x minus 3. That's what happened there. So in the place of the x, you just write a cos. And then you solve x, so you get cos x is minus a third, or cos x is 3 over 2. And then this one is not applicable because 3 over 2 is bigger than 1, then it's not applicable. Then I'm zooming in on cos x is negative a third. What you do is you ignore the minus and you say second function cos a third, and you get a reference angle of 70,53. And then you say, so where is cos negative? Here's the cast diagram up here. Cos is negative in the second and the third quadrant. So in the second quadrant, it is x is 180 minus the reference angle, which is 70,53. And then when you do the calculation, it's x is 109,47 plus k times 360, k element z. Or cos is also negative in the third quadrant. So it's x is 180 plus the reference angle, which is x is 250,53 plus k times 360, k element z. And then where's the marks? The identity. the standard form, the factors, both solutions for cos x, the answer 109, the answer 250, plus k times 360, k element z. That's also worth a mark for you. 6.4, given x plus 1 over x is 3 cos a and x squared plus 1 over x squared is 2. Determine the value of cos 2a without using a calculator. Alright, so this is what we are working towards, but we are going to start with what was given. So what I did here was I took this first bit, I just wrote the 3 cos a on the left and then the x plus 1 on the right, and then I squared both sides. And you can do that as long as what you do on the one side you do on the other side, you can do it. And then on the left it becomes 9 cos squared a, and then here on the right hand side it was x plus a 1 over x, x plus a 1 over x, and then you FOIL this out. So it's x times x is x squared, plus your middle term is 1 over x times x, and then your outer 1 over x times x, plus, and then 1 over x times 1 over x is 1 over x squared. And then let me show you what happened here on the middle term. It was x over x plus x over x, which is 1 plus 1, which is 2. So this whole thing is x squared plus 2 plus 1 over x squared. I wrote it there for you. Then in the next step, you find x squared plus 1 over x squared, and what was given is x squared plus 1 over x squared is equal to 2. So in that thing's place, you substitute 2. And then you get cos squared a is 4 over 9. Where does this 4 come from? 2 plus 2 is 4, and then I divided the 9 away. Then we go back to the sum. Find the value of cos 2a. So we put this one on ice just for now, and we go to cos 2a. So do you agree cos 2a is in fact a double angle? And cos 2a has 3 options, and I'm going to choose the option, the 2 cos squared alpha minus 1 option, since the rest of my sum is all about cos. And then, can you see what happened? In the place of cos squared a, there's a cos squared a, the value is 4 over 9. So I substituted 4 over 9, and the answer is minus 1 over 9. So where's the marks? Squaring both sides, the expansion of that bracket, this cos squared a, which is 4 over 9, the double angle, and the final answer.
The next question deals with trigonometry, more specifically three-dimensional trigonometry. Click on the video in the left-hand corner to take you straight to that lesson.